That's good. Welcome. Who amongst you is familiar with Django? Okay, that's most of you. That's so getting this to work. There we go. So now that I know who you are, my name is Emma. I have several years of experience writing Python. I stopped counting. I do mostly web development. I come from Belgium, and I run a small company that's called Levit. And if you want to follow me on Twitter, well, you can do so, but you can also check out the GitLab there, where there is code for most of the things I'm going to talk about. I forgot to take out my trusty mascot that is there for every single talk I do, and he's got a frame too. I'm not prepared. What can I say? So you're all here to hear me talk about Spyscript. So what is Spyscript? Well, this is Spyscript according to the website. So it's a framework that allows users to create rich Python applications in the browser. I'm not going to read everything because that's a mouthful. But in short, and this is still from the website, this is Python running in the browser. So this is not like a Jupyter notebook where the browser is just an interface and the Python is running on the server. This is Python really running in the browser. It can leverage the whole Python ecosystem. Well, not the whole Python ecosystem. Anything that is pure Python. So everything you heard yesterday downstairs about trying to make things and compile wheels in C and all that, well, that wouldn't work. It has to be pure Python, except for a few packages that have been curated by Anaconda, like NumPy and Pandas, that are not pure Python, but have been ported to work in the web as well. And Spyscript is an interface between Python and JavaScript, allowing you to go back and forth between JavaScript and Python. It also offers a few, I'm going to call them shortcuts, like buttons, predefined buttons or text areas or things like that. That part is not really the one we're going to focus on. So how does it work? Back to the talks you heard about compiling Python using C and all that. When you get to the bottom, when you compile something, you compile it to assembly language and then to code that the CPU can understand. And so people have created this thing that is called WebAssembly, WASM, which kind of emulates a CPU. So you can compile Python to run on that fake CPU, on that virtual machine. And this is the reason why only pure Python libraries will work on Spyscript, is because it's not a regular architecture, it's a fake CPU. It kind of creates a Linux-style VM in the background and runs all your code in that. It also, when you install a library, when you require a library, it will pip install that library at runtime. So, and the answer to that question, can we run Django or Flask instead of React? The answer is no. I'm sorry. The reason why is because Django and Flask, well, that's backend stuff. And Django is the most complete. It will get, the browser will make an HTTP request. There is an ASCII or WSGI server that is going to process that request, route it to a controller. Eventually, maybe there was going to be a template involved. Then the template is going to be rendered with the data into an HTTP response, and then your browser is going to be rendering things. That's how backend is designed to work. Flask is even smaller than Django. It's out of the box. It doesn't really have controllers, templates, it just has routing. So that's not how a front-end framework works. But can we still have Django running and try to get rid of that request-response cycle? Well, yes. Actually, we talked about WebSockets two talks about a few talks ago. There was a talk about WebSockets. WebSockets don't use that request-response cycle. It's a channel that is available using an ASCII server, which is asynchronous. So there could be a way to implement some type of channel that doesn't exist right now that would be triggered by something happening inside a browser, and that would call the stack that we have there, or Django, and call a controller in Django or a view.py in Django, and that would work. Of course, that has to be fully asynchronous. So yeah, but there could be some problems. Basically, Django is making progress to trying to be fully async. In my opinion, it's not fully there yet. Since the front end is basically always async, you wait for the user to do something, and you have to be there in the background and wait. So yeah, this could work, but probably not such a great idea. What about models? So since there are some PyData people here, going to precise, models is an object representation of a database item, a line in a table in the database, not a machine learning model. So could we connect directly our browser to a database? Yes, we could, kinda. In theory, we could, but the thing is that most clients for Postgres or MySQL, they're not pure Python libraries. So you cannot. You could if they were, but you cannot. Also, please don't. Even if there is a pure Python driver, please don't. Going straight to the database is something that every database provider says, please don't do it. Right now, the way we work usually is to have permissions controlled inside the application. This means that there is one user for the application that has all the rights. If you were to access directly the database, you would need to have database users with permission level set on the database and all that, and you don't always have the same granularity, so please don't. If you do, she's going to judge you. And she started doing it. What about templates? Well, the way Django works right now is the templates are only on the server. So there is a loader that loads the template, it puts data in the template, and only shows you the result of the template. If you would want to use Django in the front end, you would have to have a way to load templates in another way, because they would have to be available in the front end. That could actually be easy. There is this thing in Django that's called a template loader, and the template loader can be, you can write a custom one, so it could be a template loader that loads templates through HTTP. That would work. And usually there is no security risk in exposing templates. But after all, this is what a backend framework is, and how it could maybe be adapted to the front end. But this is not what we're expecting when we're talking about a front-end framework. A front-end framework, we're expecting something that does stuff when you click buttons, when you're filling forms. You are expecting things like variable bindings, shadow DOM, interactions, routing without loading, so without having that little spinner in the browser that says that it's waiting for something from the backend. So we're going to go a little bit over all of these points. So binding and interaction. So binding is when you change the value of a variable somewhere on the page, and magically it changes automatically somewhere else on the page. That's basically what is binding. When this came to JavaScript about 10 years ago, this was revolutionary. People loved it. Routing, so slightly different than in the backend, since once again you don't have that request response cycle. Shadow DOM, there was just a talk about ray tracing. So if you're familiar with game development, there was this thing called double buffering, where you prepare your new image in the background, and when the image is ready, you just flip the image and put the new image on the screen, and then on the one that's not on the screen, you start making the changes, the sprite advances, things like that. Then you flip that back on the screen. Shadow DOM is basically the same principle applied to the web. So you have a copy of the DOM that you can manipulate and then flip it. This is overly simplified, but that's basically how it works. And the good thing is that we don't really have to care about that because Spyscript already handles that. Async models and data. Well, Spyscript already kind of provide tools for that. It provides an async version of requests that lets you do requests to an API in the backend. So that's good. But there's nothing really that's provided in Spyscript to cache that data. So when you're writing a long-lived frontend application, you don't always have to go back to the backend to get always the same data again and again. You want a way to cache that data somewhere in the front end. And then there are other considerations. Security is one of them. Another one is WebSocket, things like that. And eventually interacting with an ecosystem that's already there, so being able to go back and forth with JavaScript. For WebSocket, Pyodite, so Pyodite is the library that's underneath Spyscript. And all that is kind of managed by Anaconda. They are the company that created it. And so they started working on the WebSocket implementation, but I wasn't able to make it work, and I was not able to make any Python WebSocket implementation work. So that's not there yet. But yeah, could we fill in the glue code and create something to really make Spyscript a framework, a front-end framework, like what we're expecting as web developer from a front-end framework? And so for that, I put a small library together. And when I say small library, it's not a pronunciation problem or typo, it's the name of the library. So small provides all what we have talked about, and it does that using, when possible, using existing Python libraries. So for routing, for example, it uses route, which is a Python library that does what it says on the box. You give it an URL, and it will match it to one of these definitions there. You can put parameters in the URLs, and you can also provide information like a component or a template render. And you can basically add as many keyword arguments as you want to that. Then when you have, I don't know, slides /3, it will give you the route to display the third slide, for example. For templates, well, there's one major templating library in Python for HTML and everything web related is Jinja 2. And yes, we can leverage that. And we can use that and put it in the code. And we can even have components that use one template per component. which is the way it's done with the web. And a component can be just a template, or it can be a template plus code. And with a little bit of code, you can pass in some arguments and some stuff to the to those components. Just a little caveat: if you put JavaScript calls inside a template, since those templates will be rendered by Python and not directly by the browser engine, JavaScript is not going to be called. So you will have to call that JavaScript manually from Python, one way or another. So the closest things to component that we have to compare in the Django world is template tags. So template tags, you have a bit of code, you have a template, you have inclusion tags that are just templates. Yeah, that's about it. So binding and interactivity. So binding, I've been talking to you about binding. So just so that everybody is clear on that, this is binding. When I type something directly, it changes a variable, and since the content of the variable changes everywhere else the variable is used, the new content is used. So and once again, this used to be revolutionary 10 years ago in JavaScript, but this is the first front-end thing in Python, so this should be kind of revolutionary as well. And so I was saying that you have to be able to pass in things to components, and since we're not really working in the same we cannot really use context as we do in a regular backend environment. We can use special syntax like most front-end frameworks do. And for example, if you look at, if I go back to the previous screen, and I lost my mouse, and you see there I am giving a byte click, and I'm also giving a prop. So those are special DSL that I came up with for Schmoll. And so prop is a property that's going to be bound between the parent. The parent is where the code is called, where you place that component tag. And the child is the component that's going to be rendered. So anything that is passed like that, so on the left side of the prop is the name of the variable on the parent. On the child, sorry, and on the right side, it's the name, the text name of the variable on the parent. So when you're going to be modifying that variable on the parent, it's going to be carried down automatically to the child. This is the data down schema that's used in most front-end framework today. And the by click is just on click, but with Python. And so by using byteclick, it's going to be calling that method on the parent if somebody clicks on the child. Yeah, that's it for this one. This is some more code for to explain what this is the code that's inside the component I just showed. So now access to API and local data. So I said that Spyscript provided a request implementation that could be used, but that does not involve caching. And for caching data, often when we do APIs, backend APIs, it's something that models a relational database. So what better way to cache it than to use a relational database? No, I told you before not to access the database directly from the front end. That's the backend database. You can have another database in the front end, the SQLite database that lives in memory in the front end, that only gets the data that it's allowed to get. And you can use that. So on top of SQLite, you can put Peewee. Peewee is an ORM. It is quite similar to the Django ORM, except that it lives on its own. So you can use SQLite with an ORN on top. And in Schmol, there is a small wrapper that lets you do fetch all and peek all. Fetch all will first do a request to the backend, populate the data in your caching database, and then select everything from there. While peek all will bypass the request to the backend and will just look inside the caching database and will give you the result that you already have uploaded in there, maybe 3 pages ago or 5 pages ago. And initializing a Schmol app is just that. It's a Schmol, it launches an application. The application, you give it the HTML element that is going to replace. You give it the name of the template that is going to use for the main application. Then you give it the router that you saw defined a few slides ago. And then you give it a list of models. So that is quite straightforward. So I bet you're all expecting to see some kind of demo, right? You want to see it in action. And I see some people saying, yes, thank you. You're probably the only one awake right now. But actually, you have been seeing a demo all along, because this is done in Spyscript. This whole slide application is done in Spyscript. And I'm going to prove it, or at least I will try, by refreshing this page. You see all that text, that's the output of Spyscript. You can actually hide that in a regular application because they provide a CSS that hides all those things. But I thought for the demo it would be nice to show it. And what I didn't show you is the routing. So if you look at the URL in the bar, you will notice that when I change slides, the URL changes. So this is full routing, and when I reloaded this page with this URL, it went directly to the right slide. I mentioned WebSockets earlier, and I was telling you that WebSockets were not working. But this is a single window, and I'm not clicking anything there, and it's still changing slides. This is because there is a WebSocket actually, but there is a Python call to a JavaScript WebSocket library. What is happening is that the callback of the JavaScript WebSocket library for onMessage is just a Python method. And the Python method then takes over and handles the call. The WebSocket itself is JavaScript. The handling of the WebSocket is in Python. You may have noticed when I reloaded the page, this is slow. The initialization of the application is very slow. And once again, this is because of the mechanism of how this works. When you load the application, it will create a VM, it will pip install everything, it will create a VM with the CPython and the standard library, then it will pip install every library that you need. So the routing, routes, Jinja, Peewee, all that, this is being pip installed while it's loading. And it's pip installed every time. So it's slow. But once it's loaded, it's actually quite fast. It's switching really nicely from one slide to the other. I have my speakers view here with my notes, and everything is kind of synchronous and all that. So once it's loaded, it's not that slow. So there is something to fix that, probably. Web services. So this is a web worker that's running WebAssembly. This web services. Service worker, sorry, is something different. Service worker allow you to cache things, and I know that they can cache web workers as well. So there's probably a way to cache your application, at least what is done by Pyodite and everything that is pip installed, there's probably a way to cache that, and service workers, they do cache very aggressively. So this is one of the reasons I even looked into that, because I heard about this a few weeks ago, and service worker cache invalidation is really hard, and you lose a lot of time, and I really didn't have that much time, because I was creating a slides application. So this is something that can probably be fixed, but it has to be looked into. So one other thing that doesn't work, I was proud to show you that the URL works and that I'm able to push new URLs when I'm going to the next page and things like that. One thing that doesn't work is the back button. So once again, this is a problem that was common in the new front-end frameworks 10 years ago. So I'm sure this is going to be fixed. The problem is that the Python callback that I'm trying to push to handle the back button gets destroyed at some point. So I'm sure this can be fixed somewhere or another. But right now, the back button just doesn't work. And so to keep talking about JavaScript, I still have a few minutes. I said I was using WebSockets. I'm also using JavaScript to highlight code. There was a bit of code that was shown in there. All the code that was highlighted by Prism, which is a JavaScript library. And so the HTML was there, and JavaScript was called from Python whenever the slide was changed. And so I guess that's it for me. If you have questions, please feel free to ask.